Innovation is a necessity to addressing the complex technology challenges of the energy transition, challenges that need to be solved if Scotland and the UK is to meet its net zero commitments. The Net Zero Technology Transition Programme is turning vision into reality. 2 years on from inception, the 7 projects involved in this programme have brought measurable contribution to net zero transition. Hydrogen Backbone Link, enabling green hydrogen projects for the UK and export to Europe. The Hydrogen Backbone Link project identified that a new pipeline from Scotland to Europe is feasible and necessary. The project also evaluated the current associated infrastructure and what could be changed over, upgraded or replaced to make this happen. Phase 2 will deliver a package ready for developing the project through to installation, as well as final connection options to Europe. Acceleration of the development of the Scotland and UK hydrogen backbone to Europe is essential as part of net zero efforts, and in turn will bring innovative technologies, jobs and establish a hydrogen export economy. Energy hubs, building infrastructure to support large-scale hydrogen production. Energy superhubs will assist in the filling of the backbone link with hydrogen. The research carried out as part of this project has culminated in the recommendation for a superhub concept to be developed. A superhub will provide centralised green hydrogen and derivatives production that will create and supply an export market, with over 90% of products being exported. It is envisaged up to 3 sites will form a superhub to help meet Scottish Government green hydrogen export targets. The next phase of this project will focus on increasing efficiency of electrolysers, as well as engaging with industry and academia to improve existing designs, develop new technology, and enhance energy hub operation. Alternative fuels gas turbines, retrofittable low-carbon power generation utilising alternative to fossil fuels. The Alternative Fuels Gas Turbines AFGT project, in partnership with Siemens Energy, focuses on retrofittable solutions to decarbonise existing power generation systems by replacing fossil fuels with lower carbon alternatives. Power generation from gas turbines and reciprocating engines is responsible for up to 70% of the CO2 emissions generated by the UK offshore oil and gas industry. Providing a route to decarbonisation for these systems will be a key enabler to reduce emissions. Retrofittable possibilities in an SGT A20 turbine using 100% methanol and associated emission savings were proven by a first-of-its-kind methanol demonstration. The next step is to fully qualify a larger, more widely used turbine such as the SGT A35. Offshore energy data architecture, empowering offshore operations through standard digital and data architecture. Accurate and accessible data is vital for an integrated energy system. The Offshore Energy Data Architecture (OEDA) project has delivered a proof-of-concept data sharing service to support decision-making, increase automation, and improve operational performance across the energy industry. The project has utilised knowledge and experience from the aviation sector, notably the Skywise programme, a data sharing service that revolutionised how organisations can run more efficiently by providing secure access to data. Building on the recommendations of the 2022 Offshore Energy Data Strategy Task Force report, OEDA has developed and given understanding to the requirements for delivering a common data toolkit to foster collaboration. The project also delivered a series of technical reports and has provided pilots on applying Palantir Technologies' Foundry platform. Data for Net Zero, paving the way for a digital data ecosystem. The Data for Net Zero D4NZ project is seeking to showcase a prototype smart energy basin to unlocking smart decision-making in the offshore energy and marine environment. It does this by recognising data as the asset and integrating various digital applications to identify emerging patterns. The pioneering research undertaken by the National Decommissioning Centre and the National Subsea Centre will apply academic rigour to vital areas. These include decommissioning of oil and gas assets, future renewable energy deployments, workforce dynamics, logistics, fishing, and other marine activity. D4NZ will bring this research together to understand and visualize the complexity of the energy transition using multiple joined-up digital twin applications. By applying data best practice and recognizing its intrinsic value, organizations can work together to create end-to-end solutions on multiple applications. This creates accurate representations of the entire basin and its capacity for future development. Advancing remote operations, preparing the energy industry for the adoption of remote operations. Remote operations have a key role to play in monitoring, controlling, and operating the complex energy mix necessary to deliver a successful energy transition. The Advancing Remote Operations (ARROW) project is equipping the energy industry with the knowledge and technology solutions needed to accelerate wide-scale adoption of remote operations. This initiative unlocks the benefits of safer, more efficient, and environmentally friendly operations, ultimately reducing the offshore CO2 footprint. Through its collaborative approach, ARROW has delivered the playbook for implementing remote operations and a wide-ranging landscape study evaluating a global cross-section of industries and recommending best practices. Offshore low-touch energy robotics, enabling the next generation of robotics and autonomous systems. Robotic applications are set to revolutionize offshore energy inspection and maintenance. They can improve safety and efficiencies, reduce cost and carbon footprint, and remove humans from dangerous and hazardous environments. The Offshore Low-Touch Energy Robotics ALTA project is addressing concerns and barriers to adoption, scalability, and commercialization of robotics in the offshore industry. The project uses a concept for a physical environment that mimics an offshore energy asset to prove the reliability and repeatability of robotics and autonomous systems. This is achieved through testing, assurance, and simulation for the future energy provision. To transition to a net zero future, we need to be able to effectively share data, visualize and test scenarios, validate and verify technologies. Maximizing this digital capability will be a critical enabler in creating the infrastructure required for multi-gigawatt scale creation of hydrogen for export through a pipeline and for the green fuels for local decarbonisation.